start trigonometry. See, trigonometry, what you learned last year and what you are going to learn this year is slightly different. Last year, we learned trigonometric ratios. Trigonometric ratios. Whereas this year, we are learning trigonometric functions. You know what a function is. Last year, trigonometric ratios, we took right triangles and we found the trigonometric ratios of angles ranging from 0 to 90 because we took only right triangles. Up to 90, maximum was 90. Then trigonometric functions means we can take the trigonometric value of any angle. Now, coming to any angle, again, you learn angles. You know that an angle is formed. When do we say that an angle is formed? An angle is formed when an initial ray, if we are reward rotation of a ray, that means two rays, see this one. This opening here, an angle is made. So this is a ray. So if this ray is rotating in this one, in this way, now an angle is formed. This red one, this is called the initial ray. Now see this opening. The initial ray, this is the terminal ray. So we have the initial ray and terminal ray. An angle is formed. You learned it. This measure, this is a right angle. A right angle means 90 degrees. So you learned it. If this is rotated, if a ray is rotated, the opening, that measure is the angle measure. You learned it. Angle less than 90, it is called an acute angle. If it is this one, 90 degree, right angle. Again, if it goes on rotating, it is an obtuse angle. Obtuse angle. Again, if it goes on, this is a straight angle. We call it as a straight angle. See, this ray is rotating. This is the initial side. Means this is the initial position, the first position. It starts rotating. Now acute angle, right angle, obtuse angle, straight angle. Again, it can go down. Now this measure, we learn it as reflex angle. Reflex angle, this one. Again, it goes on and it comes to the first position. See, actually, this blue pen, it took a complete rotation and came back to the same position. But there an angle is formed. What was the angle? This full rotation. This full rotation, that is, you learned the measure also 360 degrees. So see that now also initially, before rotation also, the position of this terminal ray. This is the terminal ray, initial ray. Initial ray means the first position. Terminal ray, when we take rotation, that keeps on moving. Terminal ray. See, initially the measure of angle is 0. And if it takes a complete rotation, now also the position of the terminal ray is same. But here the measure of angle is 360 degrees. So 0 degrees and 360 degrees both have the same position of the terminal ray. One complete rotation. One complete rotation takes it to 360 degrees. Now the question comes, can it further move? Again it can move. That means the measure of angle can be more than 360 degrees. It keeps on rotating. So like in number system, it can go to infinity. Till last year, we learned the measure of an angle maximum 360 degrees. We never considered angle more than 360. Whereas this year, see that the angle can go to infinity because this terminal ray keep on rotating it. One full circle 360. One more circle, another 360. So if we are 360 degrees, we say that the complete angle. Complete angle is 360. But not only 360. Again, that is last year. Last year, we said acute angle, right angle, obtuse angle, reflex angle. Complete angle means the angle is complete, no further angle. But this year, we are learning it can further go ahead. That means, again, keeps on rotating. That means, see, the initial ray, terminal ray, this opening, this is an angle. Again, this one. This is 30 degrees. This one, what I did, I took one complete revolution again came back. That means this is 360 plus 30, which is 390 degrees. See that? The position of the terminal ray. The position of the terminal ray for 30 degrees and 390 degrees is the same. The position is same, but actually this 390 degrees, how do we get it? This one, from the initial position, it took a revolution, it goes on, goes on, goes on, again goes on, it comes to 360, again came up, now 390. Again, the initial ray is always fixed. That is not initial, that is the first position. The first position of the ray, actually it is the same ray, first position is called the initial ray. Then the other one keeps on rotating. That is a terminal ray. At last it stops at a point, that is terminal ray. So seeing this angle, seeing the position of this angle, we cannot make it out whether it is 30 or 390. So the position for 30 degrees and 390 degrees is the same. But the actual thing is, for getting 390 degrees, after complete revolution, it went once again up. Now it is 390. So the position, see that the position remains the same, but we have taken, see, it is like, if suppose that in our school ground, we have the school ground, students running. One round is considered as 200 meters. You know, in our boys section, one round is considered as 200 meters. For 400 meters, if you are running 400 meters, you have to take 2 rounds. But see that you are taking off for 1,500 meters, you have to take 7.5 rounds. 7.5 rounds. In a 1,500 meter race, you came as a spectator, you came in between and you saw a student running in that initial starting point. Seeing him starting point, you don't know how many rounds he has taken. So one student, if he is crossing the starting point, if 2 students are crossing the starting point, the first student might have taken 2 rounds and it may be his 3rd round, whereas the second one, it may be his 1st round. But still, the position is same. But the student has taken 3 rounds, exactly same. So here, the position is same, but this person has taken one complete round and this one only starting. So the position remains same, but the measure is different. So last year we learned only up to 360 degrees. Now see that we have the measure of angle more than 360. It can go up to infinity rotation because it can keep on rotating. Similarly, last year we learned the measure of angle always positive. This year we will learn negative. How is it negative? If the measure is in anti-clockwise direction, if the measure is anti-clockwise direction, we consider it as positive angle. That means the terminal ray, the moving ray. If it rotates, if it moves in anti-clockwise direction, anti-clockwise means clockwise, anti-clockwise, and towards left. If it is anti-clockwise direction, we consider it as positive angle. Whereas, if it goes in clockwise, if it comes down clockwise, it is called a negative angle. So, last year we never learned about negative angles. This is the initial ray. The initial ray. If this is the terminal ray, if it comes into this way, this is minus 30 degrees. Here, the measure is minus 30. See that clockwise direction, anti-clockwise direction. Anti-clockwise is considered as positive, clockwise is considered as negative. You may be remembering last year in height science, trigonometric based application of trigonometry, while drawing the figure, math teacher will never draw this figure and say this angle is 30. In height and distance, so height and distance, we always have drawn the figure in this way. So that this measure, last year, whether you are drawing right, it does make difference. This is the positive direction. That's why we have drawn it that way. Here it does make difference. Now, minus 30 degrees. So minus 30 degrees, when we set minus 30 degrees, this line is only. This is, you can see, this is minus 30 degrees. Minus 30. See the terminal ray, initial ray. This is the terminal ray, OP. OA is the initial ray. OP is the terminal ray. OP is the terminal ray we have taken in clockwise direction. So minus 30. In fact, this minus 30 degrees, it is same as if you have taken the position. This one. This full is this, so this will be 330 degrees. 330 degrees. So see that 330 degrees positive, that means in anti-clockwise direction, 330 degrees. It is same as minus 30 in clockwise direction. The position of the terminal ray remains the same for 330 degrees or minus 30 degrees. So negative angle. Negative angle means if we measure the angle in clockwise direction, we call it as negative angle. So for convenience, for measuring angle in first and second quadrant, we can take the positive angle, positive direction is better. In first and second, using your protractor also, you measure this one, positive. Whereas, if the angle is in third or fourth quadrant, again quadrant, you know what is a quadrant, you learned last time. Quadrant, if the measure of angle is in third or fourth quadrant, measuring in negative direction is convenient. It is not a rule, but that is convenient. So negative direction. Similarly, so angles can be, quadrant is 1/4 of a circle, that's another definition. Here in coordinate geometry, quadrant means x and y axis divide the whole plane, Cartesian plane, into 4 quadrants we say. In the case of circle, quadrant means this sector with 90 degrees or 1/4 of a circle. Anyway, so in coordinate geometry, this quadrant means first, second, third, fourth quadrants. Yeah. So Anyway, so what we discussed is the measure of angle can be, we discussed new things. What we discussed this year, the measure of angle can be infinite. Whereas last year you had only up to maximum 360. It can be infinite because this rotation keeps on rotating. Can be infinite. Similarly, the measure of angle can be negative. Measure of angle can be negative. So one of you asked a doubt. 330 degree angle can be minus 330 also. If you measure it wrong, then how can 330 and minus 330 be different? Angle, that is what I said. Measure for measuring angle in third and fourth quadrant. Negative will be more convenient to measure for measuring. But by saying the answer, you can say 210 degrees, 270 degrees, not better. You said 390, 330 and minus 330. No, 330. What was your doubt? One of you asked 330 degrees and minus 330 degrees. Is it same? Then you will check it. Check it. 330 degrees means minus 330. No, it won't be same. How? 330. If you are measuring 330, we will check it. 330 degrees means 180, 270, 327. This is question. Minus 330 means if we start from this one. No, minus 330 is the first. Its position different. This is only 360 and minus 360 are there. 360, if it is 360 this one, minus 360 this one, position C. 330 means only up to here. Minus 330 is up to here only. It is not coming. Its positions are different. So anyway, so write these things. Write these things. Start writing. An angle is a measure of an angle is a measure of rotation of a given ray about its initial point. An angle, I repeat, an angle is a measure of rotation of a given ray about its initial point. The original ray is the initial side. The original ray is the initial side. The original ray is the initial side, and the position of the ray, after rotation, the position of the ray after rotation is the terminal side of the angle. Terminal side of the angle. Terminal side of the angle. Next line. If the direction of rotation, the direction of rotation, if the direction of rotation is anti-clockwise, if the direction of rotation is anti-clockwise, comma, the angle is positive, the angle is positive, and if it is clockwise, and if it is clockwise, and if it is clockwise, the measure is negative. The measure is negative. Then just draw this figure. This is the initial rate. This is the terminal rate. So put this angle mark. This is positive. Positive measure. Again, this one. Initial rate. Terminal rate. This one we are coming anti-clockwise. This is negative measure. This is what it is. Negative measure. Negative measure. Right. Next line. If the terminal rate, next line, if the terminal rate moves on, if the terminal rate moves on after completing one revolution, if the terminal ray moves on after completing one revolution, comma, we get angles, with measure, more than 360 degrees. We get angles with measure more than 360 degrees. So if the terminal ray moves on after completing one revolution, again it can move on. Then in such cases, we get angle measure whose degree measure is more than 360 degrees. Someone asked me a doubt. How can we differentiate between 360 and minus 360? One question. Another one, 180 and 180 will be same. Then if we change the terminal ray and initial ray, the signs of time will change, right? These are all just thinking, these are all just not genuine doubts. We are discussing it. What is it? Yeah, if it goes on, the measure of angle is more than 360 degrees. Next line. The position of the terminal ray the position of the terminal ray, the position of the terminal ray remains the same, for 30 degrees and 390 degrees. The position of the terminal ray remains the same for 30 degrees and 390 degrees. Just draw a rough figure and mark it as this one. This is 30 degrees. Again, same thing. But here, while marking it, they complete then 160. That means then write 360 plus 30. This is what we wrote just now. So the initial ray, terminal ray, the position of the terminal ray remains the same for 30 degrees as well as 300 degrees. That comes to your doubt. Even for 360 degrees and minus 360 degrees. The position is same, but the only difference is 360 degrees we measured in anti-clockwise, minus 360 we measured in clockwise. So the position remains the same. That clears your doubt, some of you. Then, next line, next point to remember. 1 degree is equal to 60 minutes. 1 degree is equal to 60 minutes. We put 1 dash. 60 minutes. That is 1 dash. And 1 minute is equal to 60 seconds. That is 1 minute is equal to 60 seconds. 2 dash. One minute is equal to 60 seconds. So these are the denominations. 1 degree is 16 minutes. Again, 1 minute is 60 seconds. Last year, you learned only degree measure. Now see, these are some denominations. Now, some examples. See, for addition, 3 degrees, 32 minutes, 40 seconds, plus 2 degrees, 12 minutes, 15 seconds. How to add? Just write an example. Adding from right to left as usual. 40 plus 15. 55 seconds. That is the 60 plus 4. 44 minutes. This is 5 degrees. 44 minutes. 55 seconds. Now, if it is 5 degrees, 40 minutes, 55 seconds, plus 3 degrees, 11 minutes, 12 seconds. Here, if you are adding from right to left, 55 plus 12. 55, see that? 55 plus 12 is how much? 67. 67 seconds. But 67 seconds. 67 seconds means it is just like our time only, like our time. We will not say 67 seconds. We say it is 1 minute and 7 seconds. 1 minute and 7 seconds. Like our usual time. We will not say 67 seconds. We will not say 67 minutes also. We say instead of 67 minutes, we say 1 hour, 7 minutes. Exactly same. 67 seconds means it is 1 minute and 7 seconds. So here 67 we write only 7 seconds. That 1 minute is carried over. That 1 minute is carried over. Now adding this on 40, 51 plus 1, 52 minutes. 52 minutes because that 1 minute is carried over from second. So 52 minutes. Then 5 plus 3, 8 degrees. So this is how to add degree measure. Say, consider our time, usual time, in usual time. What is below 40? Below 40 is below 40, that's all. What 1 minute carry? What is minute that is more than 60? Okay. Let it work. Now, similarly, for subtraction also. Subtraction, for example, 10 degrees, 25 minutes, 35 seconds. From this, 5 degrees, 10 minutes, 55 seconds. We have to subtract. For subtraction, 35 minus 55 is not possible. 35 minus 65. So we have to borrow 1 minute from this one. We are borrowing 1 minute. If you are borrowing 1 minute from this one, remember that it became 24 minutes. 1 minute is borrowed. If 1 minute is borrowed, that means how many seconds? We borrowed 60 seconds. We took 60 seconds. So 60 seconds, if you are adding 60 seconds here, this became 35 plus 60, which is 95 seconds. 35 seconds minus 55 seconds. 55 is more than 35. So we borrowed something from this one. Borrowing 1 minute means we borrowed 60 seconds. So 60 seconds is borrowed. So 35 plus 60, it became 95 seconds. 95 seconds minus 55 seconds. Now we can subtract. 95 minus 55 is 40 seconds. Now this 25 minutes, 1 minute is already gone. Remaining only 24 minutes. 24 minutes minus 10 minutes is remaining 14 minutes. This one not changed. Fighting this. This is subtraction by borrowing. You will not get any questions based on this, but just to give you an idea, that's all. This is how to add and subtract the angle measure if it is given in denominations. If it is given in denominations. Okay. Now, Yes, let me again doubt. Your doubt is if we get 52 minutes, then I take 60 minutes. Then how will you write 62? 62 minutes. We discuss it. If 62 minutes, how will you write? We will not write 62 minutes. We'll waste our time. How much time you took for a journey? Do you say 62 minutes? No. We say 1 hour, 2 minutes. Similarly, 62 minutes means 1 degree, 2 minutes. So 1 degree will be added. 1 degree will be added. Okay, now let me take your attendance. Again, yesterday also I observed few people not writing their class and roll number properly. See, it is thing is the degree measure. Now, so the measure of angle, for measuring an angle, last year we learned using protractor. This is degree measure. This year we will learn one more measure that is called the radian measure. Radian. Degree measure and radian measure. See, radian measure. Okay, you learned in physics. You are saying radian measure. So you learned in physics. Radian measure is nothing. If we are considering a circle of radius 1 unit, this 1 unit can be 1 centimeter, 1 meter, or if you are taking 5 centimeters, 1 unit, whatever it may be, 1 unit. In a circle of radius 1 unit, the length of an arc, this A, if this arc length, if this arc length AB is also 1 unit, this arc AB. See that if length of OA is 1 centimeter, length of arc AB is also 1 centimeter. If radius OA is 5 centimeter, length of arc AB is also 5 centimeter. So we consider 1 unit. This arc subtends an angle at the center. This one is called 1 radian. So radian measure is the measure the angle subtended by an arc of length 1 unit at the center of a circle of radius 1 unit. So we have a circle of radius 1 unit, and if you are taking an arc of length 1 unit, this arc subtends an angle at the center. That measure is called 1 radian. So write this radian measure. Radian measure. Radian measure. In a circle of radius 1 unit, in a circle of radius 1 unit, in a circle of radius 1 unit, comma, the angle subtended by an arc. The angle subtended by an arc of length 1 unit. The angle subtended by an arc of length 1 unit at the center. No, angle subtended by an arc of length 1 unit at the center. an angle subtended by an arc of length 1 unit at the center is 1 radian. Is 1 radian. Draw this figure. OA 1 unit, length of arc AB also 1 unit. This angle AOB is 1 radian. Draw that figure. 1 radian. Now, I hope you have drawn this figure. Circle, radius 1 unit, length of arc 1 unit, 1 radian. Now, this comes to see. This is 1 unit, this is 1 radian, right? So, this length divided by this radius. Therefore, radius, radian. Theta is equal to L by R. That means length of the arc divided by radius will give that theta. Length of the arc if it is 2 units, then it is 2 radian, where L stands for length of arc, R stands for radius. So this theta is in radian measure, not in degree measure. It is radian measure. So theta, radian, theta is L by R, where L stands for radian. You are asking a lot of questions. We will discuss it. We will discuss it. After discussing, you are asking related by radian. We are coming to it. Wait. Some of you have read those things. Okay, it is good. If you are reading in advance, it is good. But don't interfere the class by asking those doubts which is going to discuss. Theta is L by R. This means for the full circle, circumference, length will be circumference. Circumference is 2 pi r. Radius is 1 unit. See, the full length of the circle is full length. If radius is 1 unit, full length of the circle is 2 pi r. This radius is 1 unit means it becomes 2 pi. Divided by radius is 1 unit. So 2 pi divided by 1, that is 2 pi. That means for the full circle, the radian measure is 2 pi. For full circle, radian measure is right there. For full circle, radian measure is 2 pi. Why is it 2 pi? Theta is L by R becomes 2 pi R by R, which is 2 pi. Because we know theta is L by R. 2 pi R by R, that is 2 pi. For full circle, radian measure is 2 pi. Now, see, last year you learned in trigonometry, you learned some standard angles. Degree, radian. 0 degrees, 30 degrees. In trigonometry, these are standard angles. 45 degrees, 60 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. These are the standard angles you learned last year. Okay, you didn't learn 180 to 360, you didn't learn. Only till 90. Okay, now we know up to 360, not to 360. Now we are going beyond 360. We will complete later on. We know that 360 is 2 pi radian. If 360 is 2 pi, 180 is half of 2 pi, so this will be pi radian. 90 will be half of 180, this is pi by 2 radian. Now see that 180 means pi. 360 is 180 divided by 3. So 180 divided by 3, pi by 3. 45 is 180 divided by 4. So it is pi by 4. 30 is 180 divided by 6. So it is pi by 6. This is 0. 270. 270 is 90 multiplied by 3. 90, 3 pi by 3. So these standard angles you have to remember. This standard angle. So 0, 30 degrees, 45 degrees, 60 degrees, 90, 180, 270, 360. 30 is pi by 6, 45 is pi by 4, 60 pi by 3, pi by 2, pi, 3 pi by 2, 2 pi. These are the radian measure. Now, I hope you are good. So, this year, whether you say this in degree measure or radian measure, no problem. In the question, if it is asked in degree measure, write the answer in degree measure. In the question, if it is written in radian, write radian measure. Or if it is not asked, write according to your wish. No problem. The answer. But if it is asked to write in radian measure, then you write in radian measure. In the question, if it is asked to write the answer in degree measure, then you have to write degree measure. Next year, you will not be asked everything you have write only in radian measure. Next year, this year, no problem. So you should know how to convert degree to radian and radian to degree. Do we have? You have to draw this. Draw this table. One of you is asking whether we have to draw it or not. Yes, we have to draw it. Draw this table. 30 degrees. So blueprint. Now onwards, instead of 30 degrees, so instead of 30 degrees, it is 5 by 6. Radian measure is 5 by 6, 5 by 4, etc. Now how to convert this? See that we know that 360 degrees. 360 degrees is 2 pi radian. Then what will be 1 degree? 1 degree will be 2 pi by 360, which is pi by 180 radian. So 1 degree means pi by 180 radian. So for 1 degree, pi by 1. That means to convert degree to radian, multiply with pi by 180. Multiply, convert degree to radian, multiply with pi by 180. Next one, to convert radian to degree, multiply 180 by 5. That means if degree measure is given, because 1 degree is pi by 180. So 5 degrees. If 5 degrees is given, how to convert it? 1 degree is pi by 180. Then 5 degrees will be 5 into pi by 180. So multiplying with pi by 180. To convert degree measure to radian measure, multiply with pi by 180, whereas reverse. To convert radian measure to degree measure, multiply with 180 by pi. Actually, dividing by 180. If it is multiplication, it is division. Instead of division, we write multiplication by reciprocal. So remember this. Okay, and when somebody is asking, do we have to put the value of pi as for calculation? If in radian measure, you can keep it in terms of pi. In radian measure, you can keep it in terms of pi. But degree measure, we will not keep in terms of pi. So by converting to degree measure, we change pi as 22 by 7. We will do questions based on it next week. So these are the things to remember. That is first one, the measure of angle. The new things what we learned today, the measure of angle can go more than 360, can be infinite. Again, we have negative measure for angle. That is measuring in clockwise direction and anti-clockwise direction. These are new things. Then we have two types of measure. One is a degree measure and the other is radian measure. Radian measure for 360 degrees it is 2 pi. So those standard basic angles you should know the conversion means pi by 3, pi by 6, pi by 4, pi by 3, etc. These are basic. Then to convert degree to radian multiplied by pi by 180, whereas radian to degree multiplied with 180 by pi. Someone asked me whether it is coming for this exam. Yes, not only this chapter, one more chapter is coming. You have 4 chapters. Trigonometry and also complex numbers. Complex numbers is also coming for your test, which is on 21st of June. That is why next week onwards you have extra class on 2 to 3. We kept extra class also next week onwards. On Monday you have holiday. So Monday 2 to 3 you have extra class. So today's class is over. We'll meet you on Saturday. Saturday we will continue with this one. I hope you got the idea. See you on Saturday.